Let's do activity 8. But before we do that, let's just discuss the information here and the key points. RP. RP is a diameter. Very important. All right, what do we know about that? An angle in a semicircle, which is a right angle. Okay, so RP is the diameter of a circle. PQR. QS is a tangent. Again, think of the tan chord theorem, because here we have the tangent and the cos. And then PS is perpendicular to QS. We're given that information. And then prove that triangle PSQ is similar to triangle PQR. Prove that triangle PSQ is similar to triangle PQR. Right. And then if PR is 10 units and QR is 8 units, calculate the length of PQ and the length of QS. We're going to do that after we've proved our similarity. Okay, let's start. Right, as usual, let's start by matching our angles. So P, or let's just highlight our triangles. PSQ, that's triangle PSQ, and then PQR, that's triangle PQR. So angle P, it means P1 for triangle PSQ. So it means angle P1 will go with angle P, it means P2 for triangle PQR. So P2 for triangle PQR. And then the next one is angle S and angle Q. Angle S for triangle PSQ is angle S there. It's fine. And then it goes with angle Q. So it means it should be Q2 if you check. Q2. Right? And then the last pair will be angle Q in triangle PSQ, it will be Q1. And then it goes with angle R in triangle PQR, so it means that is angle R. Okay, so now in triangle PSQ and triangle PQR. Now let's write our statements with reasons. So we're going to start with which angle? We're given Q2 there. Well, we're not given Q2 there, but we know it is subtended by diameter, so it's an angle in the semicircle. So this is 90 degrees. So we can say that Q2 is equals to 90 degrees y angle in semicircle. Right? Okay. And then we're given that angle S there is what? Is 90 degrees. Okay. So we can conclude and say, or we can, let's start by writing that angle S here is equal to 90 degrees. We're given that. We're given because they said PS is perpendicular to QS. So therefore, we can say now, we are starting with triangle PSQ. So we're going to say now angle S is equals to angle Q2, because both of them are equal to 90 degrees. So this angle is equal to this angle, right? Okay. And then we go to the second pair, the tan chord theorem. The tan chord theorem. So we're starting with triangle PSQ, so it's Q1 there. So we can say Q1, angle Q1 is equals to angle what? Angle R. Okay, angle R, because it's what? Because of the tan chord theorem. So these two are equal because of the tan chord theorem. And then we have the last pair, which is going to be P1 and P2. Okay, P1, angle P1 is equal to angle P2 because of what? The angle of triangle. Right, now we've managed to prove that. We have three pairs of corresponding angles being equal. So we can conclude and say, therefore, triangle PSQ is similar to triangle P goes with P. You see that there, here? So P, triangle P, then S goes with Q. See here? and then Q, and then we have Q. Q goes with what? Oh, here. Q goes with R here. So PQR, we prove that. Why? Because of angle, angle, angle. Right. So we've done the first part of our question. Let's go to B. Right. We need to prove, or we need to calculate the length of PQ. If you check PQ here, or if you check triangle PQR, triangle PQR is what? It's a right angle triangle. And therefore we can use the Pythagoras theorem. And then if you check here, the Pythagoras theorem, we're going to find, we have to identify the hypotenuse. How do you identify the hypotenuse? It is the side opposite the 90-degree angle. So it means here PR is the hypotenuse. So we can say PR squared is equals to P or QR squared plus PQ squared. And then the reason, Pythagoras theorem. Okay, theorem. Right. And then we have QR and PR. So we're going to say 10 squared is equals to 8 squared plus PQ squared. Right. And then we can transpose here and say 10 squared minus 8 squared is equals to PQ squared. Then we can square root both sides, and say 10 squared minus 8 squared, right, is equals to PQ. And then that is 6 units is equals to PQ. So it means PQ there is 6 units. Okay, I had already shown you that. Okay, and then yeah, we're done with the part 1 of B. Let's go to part 2 of B. Now, how are we going to find QS now? We can't use the Pythagoras theorem here because we only have one side, which is PQ. Okay, but now we can use similarity. Remember, we managed to prove that triangle PSQ is similar to triangle PQR, isn't it? So from here we can say that PS over PQ is equals to SQ over QR is equals to PQ over PR. Then let's substitute what we have. PS we don't have, but PQ is 6. So PS over 6 is equals to SQ. SQ again we don't have, so or QS we don't have. So that's what we're looking for. QS, and then over QR is 8, so we write that. And then we have PQ is 10. PQ is 6 units, and then PR is 10. PR is 10. Now using these two fractions, then we can find our QS. You see that? So you can cross multiply here, or you just move the 8 this side and multiply. So it becomes QS is equals to 6 times 8 over 10. Okay, but even if you cross multiply, let's say you say QS over 8 here is equal to 6 over 10. You cross multiply, QS times 10 is QS times 10 is equals to 6 times 8. Then you divide by 10 both sides. You see that? Divide by 10 both sides. You get that QS is equal to 6 times 8 over 10. And therefore QS is equals to 4,8 units. Okay, done. I think we're done now. We've answered all the questions. Okay, we're going to meet in the next activities.